Dear student, today we shall discuss about kinds of functions. First we discuss about one function or injection. Its definition is a function f from a to b is said to be one function or an injection if different elements of a have different images in b. That is, f is a mapping from a to b is said to be one mapping or function if and only if a is not equal to b implies fa is not equal to ab for all ab belongs to a. That is, if preimages are not same, that is, if preimages are different, then images are different. Or if and only if fa is equal to ab implies a is equal to b for all ab belongs to a. That is, if images of two elements are same, then the elements are same. That is, if images of two elements are same, then the preimages are same for all ab belongs to a. Look at the diagram. Here a is a set, b is another set. A1 is related to B2, A2 is related to B4, A3 is related to B1, A4 is related to B3. That is, B1 is an image of A3, B2 is the image of A1, B3 is the image of A4, B4 is the image of A2. B5 has no pre-image. So here you see that each element of the set A have different images in the set B, so it is a one function. Look here, x1 and x3 have same image y2, so x1 and x3 are two different elements, but they have not different image, they have same image y2, so this is not one function. Next, we shall learn about many-one function. A function f from a to b is said to be a many-one function if two or more elements of a set A have the same image in B. That is, f maps a to b is a many-to-one function if there exists x, y belongs to A such that x is not equal to y but f of x is equal to fy. That is, preimages are different but their images are same. Look at the diagram. This is a set, this is the set B. A1 is the preimage of B1, A2 is the preimage of B2, A4 is the preimage of B2 also. Here A2 and A4, they are different, but their image B2 is same. So this is a many-one function. Again, look at this diagram. Here also y2 is the image of x3 and x4. That is, x3 and x4 are different, but their images same. Again, y4 is the images of x1 and x2. That is, x1 and x2 are different, but their images are same. Here it is y4. So G is a many-one function from x to y. F is also a many-one function from A to B. Next, we shall learn about onto function or surjection. A function f from a to b is said to be an onto function or a surjection if every element of b is the f image of some element of a. That is, if f of a is equal to b, that is, image set is equal to the codomain set, or range of f is the codomain of f, then we say that the function is an onto function or a surjection. If a function f from a to b is an into function if there exists an element in b having no preimage in a. In other words, f maps a to b is an into function if it is not an onto function. Look at the diagram. Here b2 is not an image of any element of the set A. b5 is not an image of any element of the set A. The image set consists of the elements b1, b3 and b4, and codomain set B, it has the element b1, b2, b3, b4, b5. So here image set is the subset of the codomain set B. So this is an into mapping or into function. Again here you see y1, y2, y3, y4. Every element of the codomain set Y is an image of the element in the set X. So here the codomain set and the range set or image set is equal. So G is an onto function from X to Y. Lastly, we shall know about bijection or 1-1 onto function. A function f from a to b is a bijection if it is 1-1 as well as onto. A function f from a to b is a bijection if it is 1-1 and at the same time it is onto. That is, a function f from a to b is a bijection if it is 1-1, that is, if fx is equal to fy, then x is equal to y for all x, y belongs to a. And secondly, for all y belongs to b, there exists x, an element x belongs to a such that f of x is equal to y. That is image set is equal to codomain set. Range set of f is equal to the codomain set. Then we say that the function is a bijection or 1-1 onto function. Look at the diagram. Here f is a function from a to b and a1 is the preimage of b3, that is b3 is the image of a1, b4 is the image of a2, b1 is the image of a3, b2 is the image of a4. That is, each element in the set A has separate images in the set B. Again, each element in the set B has preimage in the set A. So here f is 1-1 as well as onto. Onto because image set contains b1, b2, b3, b4 and the codomain set also contains the same element b1, b2, b3, b4. So image set and codomain set, they are same. So it is onto. And since each element of A has different images in the set B under the function f, so f is 1-1. So that the function f from n to n, that is f is a function from the set of natural number to the set of natural number given by or defined by f of x is equal to 2x is 1-1 but not onto. To show it is 1-1, we take two elements x1 and x2 belongs to n, that is in the domain set n, such that f of x1 is equal to f of x2. Then f of x1 is equal to f of x2 implies 2x1 is equal to 2x2, 2 cancelled, then x1 is equal to x2. That is different images, so elements are same. So f is 1 1. Again, the range set contains only the even number. So odd numbers are not images of any element in the domain set. So it is into function, not an onto function. Prove that M maps R2 R given by f of x is equal to 2x is 1 1 and onto. Look here. Here the sets are set of real numbers. Here the sets are set of natural number. When the codomain set is natural number, the definition is same, but it is not. In this case, the function is not onto, but in this case, the function is onto. Look here. For x1, x2 belongs to the domain set R, if f of x1 is equal to f of x2, then 2x1 is equal to 2x2, that is x1 is equal to x2. So f is 1 1. Let y be any element, any real number in the set R, that is in the codomain set R. Then f of x is equal to y implies 2x is equal to y, that is x is equal to y by 2. For any real number y by 2 is a real number, so x is real. So for any real number y in the codomain set, there is a preimage y by 2, that is x, in the domain set. So we say that the codomain set and range set is same. So here the function f is an onto function. Let us take another example. Show that the function f from the set of real number to the set of real number given by f of x is equal to ax plus b, where a, b belongs to R, that is real number, and a is not equal to 0 is a bijection. So we have to first prove it is 1 1, then 1 onto, then it is a bijection. For 1 1, let us take x and y are two real numbers in the domain set R. Then f of x is equal to f of y implies, according to the definition, ax plus b is equal to ay plus b. B cancel out, then ax is equal to ay, that is x is equal to y. Thus images are same, elements are, that is preimages are same. So the function is an injection. For surjectivity, let us take any element y in the codomain set y, then in the codomain set R, then f of x is equal to y implies ax plus b is equal to y, f of x is equal to ax plus b by definition. Then from here ax is equal to y minus b and x is equal to y minus b by a. Now for any real value of y minus b is a real number and y minus b by a is also a real number. So y minus b by a belongs to the domain set R, that is x belongs to the domain set R. That is, for any y belongs to the codomain set, there exists an element x in the domain set. For any element in the codomain set, for any element y in the codomain set, there exists an element x in the domain set such that f of x is equal to y. So codomain set and range set is same. So we can say that the function f is an onto mapping, that is f is 1 1 mapping as well as onto mapping. So f is a bijection from R to R.